Okay, cool. Awesome. So I'll go ahead and also share my screen, just as always. And let me just pull up the chat. So I could see that on my end. And then last thing will be just to get this going. Okay, awesome. So hello everyone. So let's just start with like a little bit of review from last class. So last class, we kind of ended our discussion in discussing some of the limitations of science. Or no, sorry, we ended our discussion in discussing some of the assumptions behind science. So the types of things that scientists have to assume in order to do scientific research in the first place. Now, for today's class, we kind of actually started last class talking about the limitations of science, but today we're going to talk in more detail about these limitations. Now, you'll notice that these limitations are closely connected with the assumptions behind science. So insofar as science has these limitations, we have to make certain assumptions. And you'll see that in just a moment. One of the main assumptions you'll notice that we have to make is the assumption that we live in an orderly and predictable universe. Now, before we get there, so before we kind of get into the nitty-gritty of the limitations of science, I want to remind you guys that science is considered an empirical enterprise. So science is a form of empiricism. Now, what's empiricism again? So science prides itself on being empirical. It's a form of empiricism. What's the view of empiricism? So it's a view concerning how we can derive knowledge, right? So what's the view again? Okay, awesome, Zachary. All knowledge comes from experience. So all knowledge comes strictly from experience. Dylan says the only source of real knowledge about the world is via direct experience or physical senses. Yeah, so all knowledge comes strictly from experience. I'll also put up what Dylan says. The only source of real knowledge about the world is via direct experience or via, physical senses. Okay, awesome. Now, in a moment, you'll see why I'm reminding you of the assumption of empiricism, because in a moment, we're actually going to see that strictly speaking, scientific theories and hypotheses are not solely empirical. So in other words, we have to utilize some other forms of reasoning and inference in order to develop scientific theories and hypotheses. And as you'll notice, if scientific theories and hypotheses were strictly empirical, so the only claims that are made are strictly derived from observation, well, we actually run into some problems. And this will be illuminated when we talk about the underdetermination of theories and hypotheses in science, which is going to be the second limitation of science we're going to discuss in just a moment. But just remember, this concept of empiricism as we get there. Okay, so let's get into some of the limitations of science. So there's a whole host of limitations. So if you've taken critical thinking with me, we focus actually on different ones. But there's only two that I really want to focus on for our class. So for this philosophy of science class. And the first limitation is often just called the problem of induction. The way to understand the first limitation is to see that given this limitation, we need the assumption in science that we live in an orderly and predictable universe. So what is the problem of induction? It's just the following, okay? We tend to think that observations we make justify, right, some expectations or predictions about observations we have not yet made, or that the observations that we make justify some expectations or some justify more generally some claims that go beyond the observable. Okay, so here are two examples of these two different types of cases. So observations justifying some prediction and observations justifying some general claim. And notice that this is very, common in science. So here is an example of what's stated first in point A, which is just the following. And we talked about this last class as well. So I've observed the sun rise, for example, millions of times in the past. And so therefore, I come to the conclusion that the sun will likely rise tomorrow, right? So in science, we utilize past instances of observation to justify claims that concern the future, right? So I observed this thing in the past millions and millions of times. And so I'm going to make a justified claim that the sun will rise tomorrow, right? So something I have not yet observed. This is how induction works, right? So inductive arguments, you utilize past observation to come to a likely conclusion that the future will conform to the past, okay? Also in science, so science is a lot about making predictions about the future, but science also is just about coming up with general theories that help us explain things, in the world. So another way in which kind of this scientific induction works is in the following example. Okay, I've observed millions of times that people with Down syndrome have 3 copies of chromosome 21. And so therefore I come to this kind of general conclusion, right? This general claim that a salient cause for Down syndrome is having 3 copies of chromosome 21. So I utilize past instances of observation, right? In this case, let's say I've observed it millions of times. I'm a researcher, so I'm a neurologist. I research this, or I don't know, I'm some kind of doctor who researches this. And I've noticed, right, almost every time I've seen someone with Down syndrome, I've noticed that they've had 3 copies of chromosome 21. And so I come to this general conclusion based on those observations, right? That, a person with Down syndrome likely has 3 copies of chromosome 21. Okay, notice for both these examples, right? We're moving from the observed to the unobserved. Right? So for the sun rising example, I'm utilizing past observations to make an inference about the future, which I have not observed yet, right? So to make an inference about an unobserved future state, correct? And for the second example, I'm doing something similar in the sense that I'm using past observation to make some kind of causal claim that of course I have not observed most generally, right? So in other words, I'm utilizing all these past specific observations to make a very general claim about the causal nature between having 3 chromosome 21 and having these characteristics of Down syndrome. But of course, I have not observed this direct cause. Okay, but in both cases, the whole point, if the second example is tricky to you, you can just focus on the first example. But the point is that, in science, when we make these inductive arguments, right, what we're doing is we're utilizing observation to make some prediction about something that has yet to be observed, right? Now, notice, and I know we kind of talked about this last class, and maybe this is something that's a little bit of review. Notice that we can't make these types of inferences without assuming that we live in an orderly and predictable universe. So let's focus on the sun rising case, right? So when we look at the sun rising case, right, for example, the idea is that we can't infer that the sun will rise tomorrow based on past observation without assuming that future states will conform and be similar to past states, right? So now let me actually just erase this and we could focus on this example, right? So I can't reliably tell you that the sun will rise tomorrow strictly based on my past observations of the sun rising, all these past days. I can't tell that to you. in a reliable way without assuming that we just live in an orderly and predictable universe, right? But notice that this is just an assumption, right? So this is just an assumption scientists have to make. In other words, right, we can't utilize the tool of induction and empiricism or scientific reasoning, right, to prove that future states will be similar to past states, right? So I cannot be certain, right, that the sun will in fact rise tomorrow based on all my observations that it has risen in the past, because I don't know for sure that the future will be similar to the past. And notice you may be thinking, okay, well, so you may be thinking this, actually, so let me actually put this up on the board. So you may be thinking something like this, like, well, you know, of course we know that, I don't know, you're thinking, given that the past has always been, you know, conformed, so given that the past has always had the same kind of structure, right? So given that the past has always been predictable, Professor Cossum, can't we assume that the future will conform to the past? But notice we can't really do this. So we can't utilize induction to justify this assumption because, of course, right, induction is all about making inferences from past observation to make predictions about the future, right? To come to some conclusion about the future. But here we're trying to understand whether in the first place, the future will in fact be physically similar to the past. So in other words, right, even just because I've observed the sun rise millions and billions of times does not imply that it's going to rise tomorrow, right? I just don't know this for sure. I just have to assume that we live in such a universe where, you know, tomorrow will be very physically similar to the, you know, past. But this is just an assumption I have to make. And this is what we call the problem of induction. So the problem of induction is, again, just that. And let's look back on point A. We tend to think that observations we make justify some predictions or expectations about observations that we have yet to make. So things we have not observed just yet. But we don't know that for certain. And insofar as we don't know that for certain, we have to just assume that the future will conform to the past. So this is just an assumption that we have to make. And it's not a type of thing that we can actually justify using the tools of science, using empiricism, and using induction. Okay, so this is the first limitation of science. Now, we kind of talked about this last class, so I won't say much more here. Now, the second limitation of science is kind of related, though it is different. And this second limitation of science will be more the focus of today's meeting, because this second limitation, from this stems like kind of a whole host of new kind of questions and issues concerning scientific methodology. So now let me erase this and put this up on the board. So the second limitation in science is called the underdetermination of theory by evidence problem, right? So this idea that for any scientific hypothesis or theory, it's underdetermined by the available evidence. So now let me put this up on the board. When more than one hypothesis, underdetermination, one way of kind of understanding what this is when you have more than one hypothesis or theory that's compatible with the available evidence. Okay, now you may be wondering, okay, like, so what? Yeah, there might be instances where you have evidence and there's more than one hypothesis that's ratified by that evidence. So it's just a particular problem that arises sometimes in science. But no, actually, this underdetermination problem happens for every single scientific hypothesis or theory. Okay, so for every single hypothesis or theory that you have come to believe in science, there is a competing hypothesis or theory that is justified by the exact same empirical evidence. Okay, and so this is a huge problem. Now, the way I'm going to kind of talk about this is I'll talk through some examples. The first example, the first example I give maybe is like, it's more kind of a philosophically deep example, but it's supposed to just show you that, even the most basic hypotheses you have about just the nature, let's say, of what you're observing, there is always a competing theory that is just as justified and that you cannot rule out by means of strictly using empirical evidence. Okay, so let's look at the examples and hopefully that will make this point clear. Okay, so here's an example. I'm having a perception, or I'm making an observation right now, right, of the world. And based on that observation, I conclude something like the following, right? So I'm observing right now. So we're all actually hopefully doing this. We're all right now making an observation. What is that observation? Well, we're all making an observation, hopefully, of our computers in front of us, right? So I'm observing right now my laptop in front of me. You're observing right now either probably your laptop, PC, or smartphone in front of you. And so based on this observation, right, I come to the conclusion, let's say, that my computer exists outside of me, right? There's this thing I'm looking at, namely my computer, that exists outside of me. Okay, so what's my evidence here? My evidence is just the observation I'm currently making of my computer, right? So this is my evidence. And what's my hypothesis? My hypothesis is that there's a computer that exists outside of me. Okay, super simple hypothesis justified by pretty clear evidence. Now, notice actually that my observation used as evidence in this case can actually justify two competing hypotheses. So here are the two competing hypotheses now that I'm going to put up on the board. So again, I'm using the same evidence, the same evidence, which is just my observations of the computer, and I'm utilizing that, to justify two competing claims. Let me see. Let me get this up on the board. So two competing hypotheses. So what are these two hypotheses? Okay. So again, based on the same evidence, just me observing right now through all these different modalities of perception, I'm seeing this computer, I'm touching it, right? I can kind of feel it, I guess. So if I touch the computer, I notice that it's there via touch, but also I feel its warmth or something. I hear things from it. Okay, so I'm making all these observations. That's my evidence. And I come to the following first hypothesis, right? I've observed this computer, and therefore this computer exists outside of me. Now notice that the same evidence can come to justify the second hypothesis, okay? I've observed this computer, and therefore, I don't know, I'm in the matrix, or I am dreaming, right? And this computer does not exist outside of me. Now, these are two competing hypotheses. And notice that the same exact evidence serves to justify both, right? So let me say a little bit more about the second hypothesis. You can think to yourself, okay, right now I am observing a computer as I'm listening to this lecture or whatever, but, it could be the case that this observation you're making of a computer is really in a dream that you're having right now, a really elaborate dream, like you're having a really, really realistic dream. Or even more trippy and out there, you're actually right now, what you really are is just a brain in a vat, and your brain is hooked up to a machine such that you're having this experience of this lecture, but really there is no computer out there, and this is all in your mind, right? Okay, now the point, just for the present purposes, is that the same exact evidence can come to justify these two competing hypotheses. Now, you may think to yourself, right, that it's odd. You may be thinking, okay, Dr. Qasim, she's crazy. She's a philosopher. Like, this is just so bizarre. Because of course, the first hypothesis is the correct one. And of course, the second one is the incorrect one. You may be thinking that. Now, let me ask you, what evidence do you have to justify that claim? What evidence helps us conclude that hypothesis 1 is the correct one and hypothesis 2 is incorrect? So what would justify that claim? Is there any evidence you could point to? Any empirical evidence that can help you determine 1 is correct and 2 is incorrect? Thoughts? So I know this is kind of tricky, but just try to just think. Okay, so hypothesis 1 versus hypothesis 2.
Are you asking why you can't prove the second one, Professor? Just a little confused on that.
I guess I'm asking, maybe like the question is, I don't know. But what I'm asking is, okay, it may seem obvious to you, right? That hypothesis, I mean, of course we like to think that hypothesis 1 is correct, right? And it may seem obvious to you that hypothesis 1 is correct and hypothesis 2 is incorrect. And now I'm just asking, if you were to make the case for hypothesis 1 or over hypothesis 2, what type of evidence would you provide? That's the question. And so I'm seeing in the chat, Zachary says no difference. Shelby says you can make observations outside the computer that support the first hypothesis and the second one is wrong. So Shelby, it was kind of like a facetious question because strictly speaking, right, the answer is no, right? Because whatever observations that you make satisfy and justify both hypotheses, right? So you may be thinking, okay, well, I could observe, I don't know, I look outside, above my computer and I see my cat and, I hear my mom in the other room. And so I come to the conclusion that, of course, right, hypothesis 1 is the correct one, because otherwise, why would I have all these interactions with, I don't know, my cat and my mom, etc. But of course, you could just be having a really elaborate dream, right, where your mom is in the background, your cat isn't in the dream, etc. So really, right, there's no empirical evidence. Empirical evidence alone, right? So observation alone cannot help you claim that hypothesis 1 is correct and hypothesis 2 is incorrect. So says Zachary, there's no empirical evidence to differentiate either. And that's exactly right. Or in other words, the same observations serve to support both hypotheses. Now you may be thinking this is this is a really out there example, but this is true now of any scientific theory or hypothesis. So now I'm going to put this up on the board. For any scientific theory or hypothesis that's supported by some empirical evidence, there's always going to be a competing theory or hypothesis that's supported by the exact same empirical evidence, such that empirical evidence alone, observation alone, cannot determine the truth of one over the other, okay? So in this case, right, my observations alone cannot help me determine whether hypothesis 1 or hypothesis 2 is correct, right? Because of course, if I am in a dream, so if I am dreaming, I'm going to have a similar kind of observational outlook as if I'm not, right? So I can't disprove hypothesis 2 by means of mere observation, right? And I cannot prove that hypothesis 1 is correct and 2 is incorrect by mere observation. Because again, think about it. If I was in a dream, I would be making the same types of observations, right? And I wouldn't know that those observations were just, dream states, essentially. Okay, and so this is what we mean when we say that scientific theories are underdetermined by evidence, by empirical evidence. So if we can find some reason to say that a dreaming world maybe, or being in the matrix, I don't know, is less likely than being in the real world, then of course we can make a choice between these two theories, right? So if there's some reason I can point to say, well, look, it's just more likely right now that I'm actually, looking at my real computer giving this lecture as opposed to dreaming, right? Then of course I can give a justification for why hypothesis 1 is correct and hypothesis 2 is incorrect. But notice that this justification will never strictly come from my empirical observations alone. So here's another example now to make this point clear. So I'm going to talk through another example. If you've taken critical thinking with me, which actually now I'm noticing like a number of you have, I've used this example before. So, I think you'll be able to kind of figure out where I'm going with this. Okay, but suppose, it's next week, it's February 7th, whatever, we're back on campus, and you park your car in the giant parking structure, which I know we're all kind of dreading. The parking situation, as always at Fullerton, is kind of a mess, right? So it's always hard to find parking. Okay, so Dylan, this discussion relates to a whole host of different philosophical issues in epistemology. So you're right to bring up Sosa. But I'm not going to get into, so it has to do with skepticism too, but I'm not going to get into that because we're just focusing on philosophy of science here, but good point that you raised. Okay, so anyways, we're back on campus. The parking situation at Fullerton is a mess. So I'm walking around, so I park my car somewhere. Of course, as always, I'm in a rush to get to class. This is kind of true of me, to be totally honest with you guys. So I park my car and I just run to class. I start sprinting to class to get there on time. Now, suppose this is you, right? So suppose you finish your classes for the day and you're walking back to your car to drive home, and you notice that your car is not where you remember parking it, right? And let's say now you look all over the parking structure and you can't find your car. Okay, you just cannot find your car in the parking structure. And so, based on this evidence, right, based on this evidence that your car is not in the parking structure, you come to the following two hypotheses, okay? So the first hypothesis is the following. I don't see my car in the parking lot, and therefore, I'm coming to the conclusion, based on this evidence, that my car must have gotten towed, right? So you think to yourself, well, I don't really remember all the parking rules of Fullerton and if I had the right permit and yada, yada, yada. So insofar as I cannot find my car right now in the parking lot, it might have been towed. Okay, so that's hypothesis 1. Hypothesis 2, I don't see my car in the parking lot, therefore my car was abducted by aliens. Okay, so you're like, oh man, I looked all over the parking lot. I can't seem to find my car. So aliens must have took it. Okay, now question. Which hypothesis is more plausible and on what grounds? So what do you guys think? Which hypothesis is more plausible?
Hypothesis 1.
Okay, and why? So good, hypothesis 1. Okay, and on what grounds? So this is a trickier question. So I think we'd all say hypothesis 1 is more plausible, but on what grounds is it more plausible? Okay, so Zachary says alien abductions aren't very common. Awesome. What else? Any other thoughts? So maybe some of my critical thinkers might have something to say, but if not, that's fine. Isn't this based solely on empirical evidence? Yeah, so I have a couple things to say about this example. But I was just kind of seeing what else people had to say, assuming predictability, hypothesis 1 is more likely. Okay, so you guys are right. So Zachary and Kazra, you guys are correct. So hypothesis one is more plausible. In this case, actually, we could say that hypothesis one is more plausible based on empirical evidence. So we can think to ourselves, okay, in the past, I've noticed that when I can't find my car, it's usually because it's been towed and not because aliens have abducted it, right? So you're utilizing some kind of past knowledge that you have based on experience to help you come to the conclusion that hypothesis one is more likely. This actually happened to me before. So I once parked my car in this parking lot in downtown Los Angeles, and I get there and I just cannot find it. And then I think that I forgot where I parked it. So I actually ended up searching every single parking lot in downtown until I found out that my car actually got towed. So I don't know, real world example, this actually happened to me. Okay, so yeah, exactly. So I'd utilize that past experience, that empirical evidence to come to the conclusion, right, that hypothesis one is more likely. And this would be a totally empirical, kosher way of doing this. Now, there's also another reason why I can come to the conclusion that hypothesis one is the more likely scenario. So the hypothesis one is probably more accurate. Any thoughts on this? Yeah, so exactly, Zachary. Assuming predictability, hypothesis one is more likely. There's also another reason. So if you took my critical thinking class, maybe you kind of remember this. So there's another reason why hypothesis one is something that me as a scientifically minded person I would be more likely to accept. So it's not just based on the empirical evidence, but there's another reason too. Any thoughts on this? Kind of a tricky question. So the other kind of grounds I have for going with hypothesis one over hypothesis two, independent of the empirical evidence, is a certain value that we utilize in science. And what's that value? It's simplicity, right? So notice that hypothesis one is just the simpler theory, right? It's the simpler theory because it posits less assumptions, right? So it's a lot simpler for me to, think to myself, okay, my car got towed, than for me to be sitting there thinking, okay, well, aliens abducted my car. So first of all, aliens are really interested in me. Second of all, aliens exist. Third of all, aliens have the technology to come and take my car, right? So notice hypothesis two makes a lot more assumptions that are needed to be justified. And so another reason why I would go with hypothesis one over two is its simplicity, right? It's a simpler hypothesis, and therefore, yeah, Occam's razor. So it requires less justification. So there's two ways of spelling Occam's razor, by the way. Kazra, sorry, you have your hand raised.
Just a quick question. I believe you answered this, but I was just confused earlier then. For the first example you gave, why couldn't we say the first hypothesis was more plausible than the second one? Because I thought it was just solely based on empirical evidence that you can't do that. But then this one here, it's solely based on empirical evidence. And we were able to say that one is more plausible than the other one.
Okay, so that's actually a really good question. I was actually just going to get back to that because I chose these two different examples on purpose. So you're right. I didn't make the same claims in relation to the first two hypotheses. So the first example about the computer, because notice in this case, I have the same evidence, but I can actually rely. So in this case, I can rely on some other past external evidence to kind of help me arrive at, the conclusion that hypothesis one is more likely to be true. It's kind of a more so, the reason why I brought that up was because some of you guys in the chat have already mentioned that. So I thought, okay, I should mention this. But notice, right, with these two hypotheses, I can kind of rely on past evidence I have that, okay, in the past, I've noticed that whenever my car has gone missing, it's been towed as opposed to aliens abducting it. And so in this instance, it's probably likely that my car got towed instead of aliens abducting it, right? So that's like one kind of strictly empirical reason that I might go with hypothesis 1 here over hypothesis 2. So in this case, I actually do have more evidence, I guess, to support hypothesis 1. But in conjunction with that evidence, right, also as well, I noticed that hypothesis 1 is the simpler theory. Now, in contrast, so now let's go back to the first example. So let me actually clear this. So in contrast with this example, notice that there's no evidence that I could utilize that can make me sure that hypothesis 1 is correct and hypothesis 2 is incorrect, right? Because for whatever evidence serves to support hypothesis 1, it would serve to support hypothesis 2, right? So whatever evidence you may try to utilize to say hypothesis 1 is correct, I don't know, I'm observing this computer, I can see my cat outside, I don't know, I can see my partner, all this stuff I'm noticing, right? Therefore, I come to the conclusion that this computer exists outside of me. Even also, all the past times, I've observed my computer, I come to this conclusion that it exists outside of me. Notice that all of those observations serve to ratify and justify the second hypothesis in the exact same way, right? Because of course, if you're in this elaborate dream, or I don't know, your brain is hooked up to a machine such that you're having these, experiences of perceiving this computer, or I don't know, you're in a coma and you're having this elaborate dream or something, you're going to have the exact same evidence, right? As if the computer actually existed, right? So both of these hypotheses are justified by the exact same evidence, right? Because think about it, if you're dreaming, right, you may think to yourself, okay, I have this experience of this computer all the past times, I've been able to touch and feel this computer, therefore this computer exists outside of me. Notice that if you're dreaming, you would come to the same exact conclusion. And in that case, the computer would not exist outside of you. You see what I mean? So this case, we don't actually have empirical evidence that can distinguish between these two hypotheses. Does that make sense? Because this is a really important question you're asking. So I want to make sure it makes sense.
Yeah, no, I get it. I get it. I get that.
Okay, so okay. Okay, so I'm seeing in the chat, we can say it's more plausible because of our empirical evidence, but we can't prove one over the other. It's just an estimated guess, right? So in this case, we can't really say much, Zachary. We can't say that one is more plausible than two based on anything empirical, because again, the exact same evidence. So it's kind of weird because you have to really think about if you were in the second case, right? So if you were really in the Matrix, or if you were dreaming, really dreaming this elaborate dream, right? The exact same evidence, you'd be having the exact same evidence, right? That would be justifying the claim that the computer does not exist outside of you. The exact same evidence is just going to be your observations, right? So in other words, really, we cannot use observation to conclude that the computer exists outside of you, right? Because those same observations can be utilized to support the claim that the computer does not exist outside of you because you are dreaming right now. No evidence can serve to support one of these hypotheses over the other. Okay, however, now let me ask you guys, what are some reasons though, given what I just said a moment ago, that may help us come to the conclusion that hypothesis 1 is just more likely to be true? So again, I just said no empirical evidence can help us conclude that hypothesis 1 is more likely, because again, you're going to get the same empirical evidence whether you're in a dream or not. Exactly. But there are other things that we can point to that may help us justify the truth of hypothesis 1 over hypothesis 2. Now, one of the things that we could utilize again is the idea of simplicity, this value. This is and we'll get to this now as we move along. Sorry, let me just move this in this course. But this is a value that scientists utilize. to help them. But that value now is simplicity, right? So we can think to ourselves like, okay, look, Professor Carson, hypothesis one is just more likely to be true because it's just a simpler theory, right? So isn't it just simpler to just assume that based on your observations, that things do in fact exist outside of you, instead of coming to the conclusion that based on your observations, you're instead in this elaborate kind of matrix, you're instead in a coma, or you're instead dreaming, or you're instead, your brain is hooked up to some electrode machine stimulating your brain to have these kind of fake perceptions. Isn't hypothesis two the more complicated hypothesis, meaning that it makes more assumptions? And yes, that's exactly right, Kazra. The simpler hypothesis is hypothesis one. But notice that this argument that you're making based on simplicity to justify hypothesis one over and above hypothesis two is not an argument solely based on empirical experience, right? It's an argument now based on something else, this value of simplicity. Okay, so notice, now let me put some of this up on the board. So notice that this type of argument requires some non-empirical reason in theory selection, which is against the spirit of empiricism. So in this is, I guess, I wrote hypothesis on hypothesis selection. But notice, right, if you make this argument that, I'm going to go with hypothesis one because it's the simpler hypothesis, notice now you're pointing to a non-empirical reason as to why hypothesis one is correct over hypothesis two. It's a non-empirical reason because it's a reason that's not strictly based on the data, right? It's not strictly based on your observations. And now we're seeing this big issue in science, the underdetermination issue, which just is that empirical data alone cannot help us decide which scientific theory we should go with. We need some other stuff in science, what's called values, to kind of help us determine and select what empirical theory is better than the other. Again, you might be thinking this is a crazy example, Professor Qasim, but I'm going to get to a real world example in just a moment. But let me just put some of this up on the board. Okay, so now let me erase some of this. So what am I getting at? Oops, this did not go transfer well. Okay, so these are supposed to be arrows. Okay, so this is kind of the structure of the discussion thus far. Empiricism, right, as a method of inquiry, which again is supposed to be what science is rooted in, requires all knowledge comes from experience. Now, experience underdetermines the theories about the natural and external world, right? So in other words, our experience can serve to support two competing theories, and we cannot choose which theory is better than the other, utilizing experience alone. And so, therefore, to further choose among theories, we must rely in science on non-empirical ways of choosing, which kind of goes against the spirit of empiricism. So this is, again, a limitation of just purely empirical science. In science, we do need to utilize other what are called values to help us select one theory over another. Okay, so in other words, there's more than one theory compatible. There's always going to be actually more than one theory compatible with the available evidence. Another way of saying this, evidence underdetermines theory selection. So, okay, then if that's true, how do we choose among theories that are equally supported by the evidence? I just showed you one way. We could appeal to this value of simplicity such that we, choose the simpler theory. But notice that this is a very tricky and also unavoidable question, right? How do we choose among theories that are equally supported by the evidence? Super tricky question. And this is actually this is a question now that scientists have been grappling with since the scientific revolution. So now I'm going to get to a real world example of the complexity of theory selection and how you can't just use evidence to decide one theory over the other. You have to use these values. And again, I'm going to show this value of simplicity and how important simplicity has been in scientists selecting one theory over another. Okay, so now let's think back to the scientific revolution. Okay, so I know we talked about this a little bit on the first day of class. You know, we didn't get to talk about it as much. So, you know, I teach a history of science class. I've taught it at UC Irvine. And, you know, in that class, we talked for the whole time just about the scientific revolution. So you could have a whole class just on the scientific revolution. This class, we only talked maybe 20 minutes about it. So let's think back to the scientific revolution for just a second. And now let's think back to Copernicus's heliocentric model. Oh, sorry. Versus, okay, Ptolemy's or the Ptolemaic geocentric model. Okay, so what's the heliocentric model of the solar system? Just to refresh our minds, what does that mean? Heliocentric model? Yes, exactly. Awesome. So it's the model that the Earth and all the planets, including the Earth, orbit the sun. Okay, now what's geocentric mean? Geocentric model? Exactly. So the planets, all the planets, including the sun, orbit the Earth. Okay, perfect. Now, good job, guys. So during the scientific revolution, right? You know, so during this period in human history, we saw Copernicus and other scientists like Galileo support the heliocentric model of planetary orbits. Now, what's interesting is that you may be, okay, so you may be thinking, why, so what was the reason for why we switched from the geocentric model to the heliocentric model? So what was the reason why there was the shift, right? What was the reason why we changed theories? And if you haven't like looked at the history, you may just assume that, okay, we probably changed theories from the geocentric model to the heliocentric just because, I don't know, the heliocentric model was more accurate in making predictions, right? Because that's what we usually do in science. When we're switching theories in science, the new theory, the reason why we usually go with the new theory is because it's more predictively accurate. Now, what's interesting about this case is actually that's not at all true. So let me put this up on the board. What accounts for the shift in our belief from the geocentric model to the heliocentric model of planetary orbits did not at all have to do with its predictive accuracy. In fact, the Ptolemaic geocentric model, this model that the planets orbited the Earth, was more predictively accurate than at this time the Copernican model, or the heliocentric model. So in other words, the Ptolemaic model was better at predicting where the planets would be at any given time in comparison to the heliocentric model. So it had nothing to do, so this switch from the geocentric to heliocentric didn't really have to do with predictive accuracy. And instead, it was argued for based on a totally different value, which was simplicity. Okay, so let me just say what this argument was, and then I'm going to show you kind of a brief video to kind of see it, because it's hard to fully grasp what I'm referring to without getting the visual. So the geocentric model, again, like we just said, was this model that the Earth is the center, right? The Earth is the center of, you know, our solar system. Now, when you look out at the stars, okay, we know now, obviously, that the Earth isn't the center of our solar system, and that instead the Earth, travels around the sun in an elliptical way, similar to any other planet. Now, because the Earth travels around the sun, and because different planets travel around the sun at a different rate, depending how far away they are from the sun, right? So of course, we're closer to the sun than Mars. So our, complete orbit around the sun is going to be faster than that of Mars, right? So because of these differences in how we orbit the sun, there's this phenomenon called retrograde motion, which is essentially when Earth passes another planet as it revolves around the sun, that planet seems or appears to be moving backwards. So if you actually look out, into the sky, and suppose you were tracking, you were tracking the planet Mars, what you would notice is it would look as if Mars, so let me draw this actually, it would look as if Mars had moved forward. Okay, so this would be Mars moving forward, and then backwards at a later time. So if you looked out and you were tracking the movement of Mars, you'd see it kind of move forward and then backward. And the real reason is because the Earth is kind of passing Mars as it's orbiting the sun, right? But of course, if the Earth is the center of the solar system, we don't have that explanation. And so in order to account for this strange phenomenon where we see planets kind of moving up and moving back, the geocentric theorists had to posit this whole kind of phenomenon called retrograde motion. Now, retrograde motion is just this, or sorry, not retrograde motion. They had to posit this whole kind of phenomenon called epicycles. Now, epicycles is just this idea that as all the planets revolve around Earth, they're actually revolving in smaller circles. So they're almost like spiraling. It's kind of a strange thing to kind of think of, but they're moving like this, according to epicycles. Because again, we have to account for why it is the case that we see kind of planets moving back and forth. And if the Earth is the center of the solar system, then the only way we can account for that is if they're moving in these kind of weird mini circles within this larger circle. So notice so the kind of main point to take away from this is just this is a very clunky, not simplistic view and theory of how planets move, right? So to support the geocentric model, we have to literally think that these planets are moving in these weird mini circles within this larger circle, which of course is a very complicated, clunky theory. And as opposed to the heliocentric model, it's very complicated, right? Because on the heliocentric model, planets just move in these very smooth elliptical orbits. Okay, now the point here, we don't care too much about geocentric versus heliocentric. The point here is just the following. We have two competing scientific theories. This is real life now. We're not just talking about whether computers exist or not. Two competing scientific theories, the geocentric model versus the heliocentric model. The evidence is actually, so the empirical evidence that we're receiving is supporting both to the same degree. In fact, it's arguable that the empirical evidence could even be supporting the geocentric model more, okay? But at the very least, the evidence is supporting these two models of planetary orbits to the same degree. Now, which theory do we go with? Do we go with the geocentric model or do we go with the heliocentric model? And the answer was, from the history of science, that we should go with the heliocentric model. Why? Not because there's more empirical evidence to support it, but instead because it's the simpler theory. And because it's simpler, we should just prefer it. But now notice that this is a type of argument. This is a reason why we accepted the heliocentric model that is not based on empirical evidence alone, right? In fact, the empirical evidence is serving to support the geocentric model better. Instead, it's an argument that's just based on something totally different, this value that we have in science called simplicity, okay? So now let me show you just a brief clip of what I'm talking about. Hopefully you guys can hear this. If not, it doesn't matter. What really matters is just if you're a little bit confused on this whole retrograde motion and the epicycles concept, you could at least see it visually in this YouTube clip. So let me just quickly show you this. So hopefully you'll be able to hear it, but if not, it's not a big deal. So I'm going to just turn this up all the way. So it might be loud, it might not be loud. I don't know. Sometimes it's a mixed bag, but here we go. Okay, wait, sorry. So this is the phenomenon of retrograde motion. Hopefully you guys can hear this. And this is
We can't hear anything.
okay. Can you guys hear me now?
Yes.
Okay, so it's okay if you couldn't hear it. That didn't really matter, but hopefully you saw the visual, right? So first it showed kind of retrograde motion, so the planet kind of moving back and forth. Then it showed how the heliocentric model can kind of quite easily serve to explain retrograde motion. So I can even just play it again. So here we have just our kind of everyday explanation of retrograde motion based on the heliocentric model. It's essentially because the Earth is passing that planet. Now, of course, if the Earth is the center of the solar system, it's not passing anything. And so why do we see planets kind of move back and forth? Well, Ptolemy posited this idea of epicycles. So as the planet is moving around the Earth, it's moving in these smaller circles, okay? So the geocentric model, notice it's very clunky, right? Because it's requiring now that planets, as they move around the Earth, are making these smaller circles. And that's like just, I don't know how else to describe it. That's just a more complicated theory. But we have at this point in the history of science the same empirical evidence that serves to support both of these competing theories, the heliocentric and the geocentric, right? And why were scientists like Galileo defending the heliocentric over the geocentric model? It wasn't because there was more evidence to support the heliocentric model. It's just because it was simpler, okay? And so we see this throughout the history of science, where the reason why we accept a certain scientific theory over another is not because there's more empirical evidence to support one over the other, but it's because of some other type of reason. So that's the main point of this discussion. And does that make sense to people? Any questions on this? So it didn't really matter if you guys could hear it because I just wanted to show you the visual. I can send you guys this video to watch later if people want to watch it. But you see what I mean? Does this point make sense to you guys? Any questions on this? Or if you're all good, you could say all good. I'm going to share the board again.
No questions.
Huh? Sorry, what did you say? I couldn't hear.
No questions, sorry.
Okay, no
All
questions. Okay, so this was supposed to be just a real world example of, again, where we pick a certain scientific theory or hypothesis, not based on the fact that it has more empirical evidence, but instead just based on the fact that, in this case, it's simpler, right? So just based on this value that we have, that, we prefer simpler theories in science. Now, you may be thinking, well, heliocentric model, that's actually the true accurate model. And you're right. So after this period after this moment during the scientific revolution later, Galileo actually will observe, so essentially telescopes become more sophisticated, and he later observes planets in such a way that supports the heliocentric model. And of course, more recently, we have so much empirical evidence to show, right, via observation, that the sun is the center of our solar system, right? But at this moment in time, when they, when these scientists were defending the heliocentric model, they did not have that evidence, and their defense was solely based on this value of simplicity. Okay, and so there's a nice kind of real world example of this. Okay, so let me clear this. And so what we're noticing, hopefully, right, is that empirical data alone is not going to help us, or is not going to determine what scientific theory we should choose over another. In other words, theory choice is underdetermined by the empirical data. And instead, when we're trying to decide what theory to go with in science, we have to utilize what's called values. And so now we're getting at the heart of, what's going to be the discussion in this course for the next couple weeks, which is the role that values play in science, right? And here for today's class, we're talking about the role values play in theory choice. So in deciding what scientific theory we should go with when we have two competing theories that are supported by the same evidence. Okay, now the first set of values that we're going to discuss in this class are what are called epistemic values, okay? So these are values that have to do with knowledge production, or values where a plausible case can be made, from them, being made from them, can be made from them being truth-seeking. So values that have to do with knowledge production, or values where a plausible case can be made that, these values actually help us get at true theories, okay? So what are some of these epistemic values? Simplicity is one. So simplicity is like so common. I just showed you so many examples of it, and we're going to even talk more about it right now. But simplicity is an epistemic value that helps us pick a certain scientific theory over the other. Simplicity helped us pick the heliocentric model of the solar system over the geocentric. It was just simpler, and scientists liked the fact that it was a simpler theory. Other epistemic values, predictive power. So predictive power is an epistemic value. It's also empirical, so that one's like kind of an interesting one. But there's another one. Here's another epistemic value, consistency, right? So if you have two competing, let's say, scientific theories or hypotheses, and let's say one is consistent with all the scientific knowledge we have thus far, and the other one is inconsistent with all the scientific knowledge we have thus far, which one are you going to go with? Are you going to go with the hypothesis that's inconsistent with all the scientific theories that we have? Or are you going to go with the consistent one? Yes, Bridget, you're going to go with the consistent one. So that's another epistemic value, again, we utilize in science to help us decide between competing scientific hypotheses or theories. Okay, so how are we doing on time? Let's see, we're doing okay. So let me talk a little bit. I'll just talk a little bit about simplicity and consistency with well-established theories. So I'll talk first about simplicity, since we've been talking about it a lot thus far. So simplicity is a value, it's an epistemic value that has helped scientists in theory choice, so theory selection or hypothesis selection, since the origins of science. Right? So since literally the scientific revolution, we've been utilizing this epistemic value of simplicity when trying to figure out which theories and hypotheses about the world are the correct ones. And so what is this value? It's just the following. If a scientist have two competing hypotheses that are confirmed empirically to the same degree, like what we saw with the heliocentric versus geocentric models, the scientist should accept the hypothesis that's simpler. Okay, and you may be thinking, well, why accept the simpler one? Why is that the case? It's based on this logical principle known as Occam's razor. So I already saw you guys writing this in the chat, like Occam's razor, and that's right. So the scientific value of simplicity is based on Occam's razor, which is just the following kind of logical principle, that simpler solutions are more likely to be true than complex ones because they make fewer assumptions. So in other words, the more assumptions that you make in a theory or an argument, the more justification you need to support those assumptions. And so therefore, the less likely that that theory or argument is to be true. Okay, so let's go back to some of these cheesy examples. I don't know, let's go back to the alien example. Because that one I think is just easy to see. So here were my two hypotheses concerning where my car is, right? So hypothesis 2 is the more complicated hypothesis. Hypothesis 1 is the simpler hypothesis. Now notice for hypothesis 2, to justify this hypothesis, I have to make so many assumptions, right? I have to assume that aliens exist. I have to assume that aliens are interested in my car. I have to assume that they have the means of abducting my car. And given that I have to make all of these assumptions, and given that all these assumptions need some type of justification, right? Hypothesis 1 is just more likely to be true, right? Because I don't have to assume as much. And the things that I have to assume are way easier to justify, right? So, my car being towed, that's not that hard to justify, that assumption. My car has gotten towed before, correct? Okay. And so the reason why we go with the simpler solution is because it's easier to justify. It's easier to substantiate. Think of the geocentric versus heliocentric model. It's easier to say, okay, planets just have these smooth orbits around the sun, instead of having to do these weird clunky mini circles as they orbit the planet Earth, right? So that's just a view that makes, or a theory, a scientific theory, that makes less assumptions. And given that it makes less assumptions, there's less justification needed to support those assumptions. So this is why we go with the simpler theory in science. Now, there's a lot of debate. So, you may, like, some scientists disagree. So, there's a whole kind of literature on why simplicity is an important epistemic value. Some people just think that, we live in a simple universe. So the universe that we live in is not complicated. And that's why we should go with this epistemic value of simplicity. But I think that this kind of Occam's razor justification to me is like the easiest and most plausible justification. So I'm just kind of putting this up on the board. But notice too that this epistemic value of simplicity, for instance, helps us show why conspiracy theories, right, are likely to be incorrect. So if you've ever met a conspiracy theorist, I don't know, maybe you know someone who's QAnon, or maybe you know someone who believes in some kind of conspiracy theory that, the earth is flat. So I think Kyrie Irving used to believe that earth is flat, for instance. So there's people like that out there, conspiracy theorists. You may wonder, okay, the conspiracy theorists, they utilize the same evidence that I have, but they come to wildly different conclusions, right? So what's interesting about conspiracy theorists is that they use the same evidence, that a normal person would use, but they use it to justify the opposite claim. So if I was talking to Kyrie Irving, and this is what he said in the past before, I don't know if he still believes this, but when he believed that the earth is flat, he would say things like, well, look, all these photos that you see of the earth being spherical, actually, those photos, they're just this elaborate hoax made by the government. And, the more photos you see of this, the earth being spherical, the more I'm justified in believing that the government is really invested in tricking us about the shape of the earth. Okay. No, so conspiracy theorists use the same exact evidence as me and you do to come to opposite conclusions than us. But notice that the conspiracy theorists have very complicated theories and conclusions about the world, right? In other words, they do not satisfy this epistemic value of simplicity. And so how can you tell the conspiracy theorists that they're wrong and you're right? You can't point to the evidence, right? You can't be like, oh, because the evidence supports my claim. No, because the conspiracy theorists will say, no, actually the evidence supports my claim that this is, I don't know, a big hoax. And instead, what you'd have to say to the conspiracy theorists is that you're wrong because you have a very complicated view, and I have a simpler theory. And therefore, there's reason to believe that the simpler theory is the correct one. Okay, so kind of interesting point. I don't know, because I feel like there are a lot of conspiracy theorists out there in the world. And so if you ever want to tell them that they're wrong, you're going to point to this epistemic value of simplicity. Okay, now another kind of epistemic value, I'll just kind of briefly mention just to get kind of a feel of what these values are that are utilized in science, is consistency with well-established theories. So let me actually put this one up now. Okay. So in deciding between what hypothesis to go with, again, here's another value that scientists utilize to pick one over the other, and that's consistency. So suppose a scientist sees two competing hypotheses that are supported by the exact same empirical evidence, okay? They're most likely going to go with the hypothesis that's consistent with all the scientific knowledge we have thus far, right? So suppose, I don't know, you're presenting a new hypothesis about concerning, let's say, how, I don't know, how female guppies select their mates. And suppose you have one hypothesis that's consistent with Darwin's theory of evolution, and you have another hypothesis that totally runs against that. You're probably going to go with the hypothesis that's consistent with Darwin's theory, right? Because Darwin's theory has been really well corroborated and justified. And so the hypothesis that's consistent with it is probably more likely to be true, correct? So this is another epistemic value that's utilized in science that helps us decide between competing theories or hypotheses when the same exact empirical evidence serves to support both. Okay. Now, I guess the last thing I'm just going to say, and this will be kind of a little bit of what we discussed thus far. So if you did the reading, this is going to be something that you've definitely noticed, is that in science, there's talk not only just about these epistemic values, okay? Of course, these epistemic values are utilized all the time. But what scientists have come to ask themselves is the following question: can non-epistemic values help us in figuring out what theory to go with or what hypothesis to go with? And so now let me just define what is meant by these non-epistemic values. Non-epistemic values are going to be social, political, or ethical values. So values that are not about truth, right? So here are some examples: fairness, social justice, profit generation. And should these type of values be utilized in scientific reasoning is the question that's going to confront us for the next couple weeks in this class. Should we utilize these types of values as well when it comes to theory selection, for instance? Or should these types of values be always off the table when we're, deciding between a hypothesis, or we're deciding whether to accept or reject a hypothesis, etc.? So this is going to be kind of where we'll pick up next class. Yeah, so I'm going to just stop for now because we're pretty much out of time. If you have any questions, feel free to ask me. I'll stick around for like a minute or two because I know there was a lot going on in this lecture. But otherwise, guys, thank you guys so much. And, I'll see you guys all next class. So in class on Wednesday. Okay, thanks everyone. Have a nice rest of your day. And
okay,
I will see you.
See that last slide that you had up?
Yes. Oh wait, let's see. Will it come
For
back?
the non-values, the non-epistemic values.
Yeah, sure. There we go. Can you see it now?
Yes.
Okay,
just
perfect.
really quickly. Thank you.
Professor?
Yeah.
I noticed that the readings for the following weeks were posted, I think today. And I was a bit worried because I assumed that we have to do readings before each class,
Yeah,
correct?
you know, that was totally my fault. So I forgot to unmute I forgot to unmute the readings. So I had posted it, but I didn't realize that they were muted. So you guys cannot see them until a student kind of informed me that like they were muted. So you know,
Okay.
not to worry, that was like totally my fault. I mean, in a perfect world, you would do the readings before class, but you know, it's not a big deal. Like as long as you just do them at some point. Um, I just think the best strategy is to skim it before class. But of course, you know, it was my fault that you guys couldn't do it before class. So, you know, these next couple class meetings, no worries. You know, I know that it was my fault if you didn't get a head start on the reading. So, yeah, so sorry about that.
Yeah, I was just wondering, like, would you want us to email you in case it ever happens again where like the module just doesn't end up publishing?
Yeah. I mean, hopefully it won't happen again. But if it does happen again, yes, please do let me know.
Yeah, because it's happened with like many professors. I had a lot of professors have that same problem last semester where the module would like seem like it was live, but then they'd find out it was never published. So,
Yeah. I mean, yeah, I would really hope that I don't do it again. But of course, if I do, please let me know because, you know, the last thing I would want is like no one being able to see the readings because of my mistake. So, um,
and just
yeah.
another quick question. I know I believe next week we're going back to in-person learning.
Yes.
Do you have like a specific criteria in terms of note taking in class? Because I have some professors who just want like a simple notebook, no technology.
Oh,
So I was just,
no, you can use whatever is, I mean, obviously, I think the reason why some professors say no technology is they don't want like people just being online. But I mean, whatever. I mean, I think whatever works best for the student. So if you're better at typing, then you can use your laptop. If you're better at, you know, writing the notes by hand, you could write by hand. Just whatever's preferable to you. I don't really mind. However you take the notes, it's fine with me. Yeah.
okay, thank you so much then.
Yeah, for sure. Yeah. I'll remind you guys all, you know, next class about us returning to in person and all that good stuff. But yeah.
All right, thank you again.
Yeah, thank you. Any other questions, guys? Dylan?
No, I just stuck around to hear that question. So anyway,
Okay, cool.
see you next
Okay,
class.
see you next class. Rachel, you're all good? I'll assume so.